In the earlier lessons, we have learnt that factorization method and completing the square method to solve quadratic equations. Consider a quadratic equation x squared plus 4x plus 2 is equal to 0. How would you solve this by any of the methods learnt? If we were to solve this by the factorization method, then we will have to split the coefficient of the middle term 4 into two integers, whose sum is 4 and product is 2. Clearly, this is not possible with integers. Therefore, this equation cannot be solved by factorization method. Similarly, completing the square method also does not work for this equation. Now, let us look at other methods of solving quadratic equations. Sridhar Acharya, an Indian mathematician in the 11th century, has given a formula to solve the quadratic equation. This formula is called the quadratic formula and can be used to solve any type of quadratic equation. Here is the derivation of quadratic formula from the standard quadratic equation. Ax squared plus bx plus c is equal to 0. Dividing the equation throughout by a, we get x squared plus b by ax plus c by a is equal to 0. Add b by 2a whole square, that is, half the coefficient of x on both sides to complete the square. We get x squared plus b by ax plus b by 2a whole square is equal to minus c by a plus b by 2a whole square. Using the identity a plus b whole square, we get x plus b by 2a whole square is equal to minus c by a plus b square by 4a square. Or x plus b by 2a whole square is equal to b square minus 4ac divided by 4a square. Taking the square root of both sides, we get x plus b by 2a is equal to plus or minus root b square minus 4ac divided by 2a. Or x is equal to minus 2 by a plus or minus root b square minus 4ac divided by 2a. X is equal to minus b plus or minus root b square minus 4ac whole divided by 2a. This is the quadratic formula to determine the roots of a quadratic equation. Now, let us apply the formula to find the roots of the quadratic equation 4x squared plus 4 root 3x plus 3 is equal to 0. The given equation is in the standard form ax squared plus bx plus c is equal to 0, where a is equal to 4, b is equal to 4 root 3 and c is equal to 3. We know by quadratic formula x is equal to minus b plus or minus root b square minus 4ac whole divided by 2a. Substituting the values of the coefficients, we get x is equal to minus 4 root 3 plus root 4 root 3 the whole square minus 4 into 4 into 3 divided by 2 into 4. X is equal to minus 4 root 3 by 8 plus or minus 0. X is equal to minus root 3 by 2 minus root 3 by 2. So, the roots of the equation 4x squared plus 4 root 3x plus 3 is equal to 0 are minus root 3 by 2 and minus root 3 by 2. The speed of the boat in still water is 8 kilometers per hour. It can go 15 kilometers upstream and 22 kilometers downstream in 5 hours. Find the speed of the stream. Let the speed of the stream be x kilometers per hour. Here, it is given that the speed of the boat in still water is 8 kilometers per hour. Therefore, the speed of the boat downstream is equal to 8 plus x. And the speed of the boat upstream is equal to 8 minus x. Time to go upstream is equal to 15 by 8 minus x. Time to go downstream is equal to 22 by 8 plus x. According to the statement of the problem, 15 by 8 minus x plus 22 by 8 plus x is equal to 5. Taking LCM and simplifying, we get 15 into 8 plus x plus 22 into 8 minus x is equal to 5 into 8 minus x into 8 plus x. 15 into 8 plus 15x plus 22 into 8 minus 22x is equal to 5 into 64 plus 8x minus 8x minus x square. On simplification, we get a quadratic equation. 5x square minus 7x minus 24 is equal to 0. Comparing it with ax square plus bx plus c is equal to 0, we have a is equal to 5, b is equal to minus 7, and c is equal to minus 24. We know by quadratic formula x is equal to minus b plus or minus root b square minus 4ac whole divided by 2a. Substituting the values of the coefficients and simplifying, we get x is equal to minus of minus 7 plus root minus 7 whole square minus 4 into 5 into minus 24 whole divided by 2 into 5. X is equal to 7 plus root 529 whole divided by 10, that is equal to 7 plus 23 divided by 10, which is equal to 30 by 10, that's equal to 3. X is equal to minus of minus 7 minus root minus 7 whole square minus 4 into 5x minus 24 whole divided by 2 into 5. X is equal to 7 minus 23 by 10, that is equal to minus 1.6. So, speed of the stream is 3 kilometers per hour. Application of quadratic formula to real-life situations. A rocket is launched with an initial velocity of 200 kilometers per second. The height h in kilometers of the rocket gained after t seconds of the launch is given by h is equal to minus 16t square plus 200t. After how many seconds will the rocket be 300 kilometers above the ground? The equation for launching a rocket is given by h is equal to minus 16t square plus 200t. Substituting h is equal to 300, we get 300 is equal to minus 16t square plus 200t. On rearranging, we get 16t square minus 200t plus 300 is equal to 0. Comparing with standard form ax square plus bx plus c is equal to 0, we get a is equal to 16, b is equal to minus 200, and c is equal to 300. We know by quadratic formula x is equal to minus b plus or minus root b square minus 4ac whole divided by 2a. Substituting the values of the coefficients and simplifying, we get t is equal to minus of minus 200 plus or minus root minus 200 whole square minus 4 into 16 into 300 whole divided by 2 into 16. T is equal to 200 plus or minus root 40,000 minus 19,200 whole divided by 2 into 16. That is equal to 200 plus or minus root 20,800 divided by 32. That is, t is equal to 10.76 seconds or t is equal to 1.74 seconds. The rocket will reach a height of 300 kilometers in 10.76 seconds on its way up and will again be at a height of 300 kilometers with 1.74 seconds left on its way down. Type of roots for different type of equations. Let 3x square plus 2x minus 1 is equal to 0. X square plus x plus 2 is equal to 0 and 9x square minus 6x plus 1 is equal to 0 be three quadratic equations. On comparing the coefficients and substituting them in the quadratic formula, we get these three distinct roots. Do you observe any pattern in the roots? The roots are real, not real, or real and equal, and the value under the square root holds the key to the type of roots. So, b square minus 4ac determines whether the quadratic equation ax square plus bx plus c is equal to 0 has real roots or not. This value b square minus 4ac called the discriminant of the quadratic equation. The term b square minus 4ac is denoted by capital D and is called the discriminant because it can discriminate between the possible types of answers. If the value of d is greater than equal to 0, then roots are equal. We get two distinct real roots if d is greater than 0 or two equal roots if d is equal to 0. But if the value of d is less than 0, we get non-real roots. Find the discriminant of the equation 2x square minus 6x plus 3 is equal to 0 and hence find the nature of the roots. Consider the equation 2x square minus 6x plus 3 is equal to 0. Comparing the coefficients with the standard equation, we have a is equal to 2, b is equal to minus 6 and c is equal to 3. We know discriminant d is equal to b square minus 4ac. Substituting the known values of a, b and c, we get d is equal to minus 6 whole square minus 4 into 2 into 3. That is equal to 36 minus 24, which is equal to 12. Since the value of d is greater than 0, the quadratic equation has two distinct roots. If alpha and beta are two distinct roots, then alpha is equal to minus b plus root d whole divided by 2a, and beta is equal to minus b minus root d whole divided by 2a. Substituting the value of coefficients and simplifying, we get alpha is equal to 3 plus root 3 by 2 and beta is equal to 3 minus root 3 by 2. The roots are not real. If minus 5 is the root of the quadratic equation 2x square plus px minus 15 is equal to 0, and the equation p into x square plus x plus k is equal to 0 has equal roots, then find the value of k. Consider the quadratic equation px square plus px plus k is equal to 0. Comparing the coefficients with the standard quadratic equation, we get a is equal to p, b is equal to p, and c is equal to k. We know that for any quadratic equation, the discriminant is equal to b square minus 4ac is equal to 0. Substituting the coefficients and simplifying, we get discriminant is equal to p square minus 4pk is equal to 0. This is rewritten as p into p minus 4k is equal to 0. So, either p is equal to 0 or p is equal to 4k. Let us consider this as equation 1. Since one of the root of the equation 2x square plus px minus 15 is equal to 0 is minus 5, then 2 into minus 5 whole square plus p into minus 5 minus 15 is equal to 0. 50 minus 5p minus 15 is equal to 0. Minus 5p plus 35 is equal to 0. P is equal to 7. Consider this as equation 2. Substituting equation 2 in 1, we get 7 is equal to 4k, or k is equal to 7 by 4. By quadratic formula, we know the two roots of a quadratic equation are x is equal to minus b plus root b square minus 4ac whole divided by 2a, and y is equal to minus b minus root b square minus 4ac whole divided by 2a. The sum of the two roots will be minus b plus root b square minus 4ac whole divided by 2a plus minus b minus root b square minus 4ac whole divided by 2a. Simplifying the above expressions, we get the sum of roots is equal to minus b by a. Consider this as equation 1. Similarly, the product of roots is equal to minus b plus root b square minus 4ac whole divided by 2a into minus b minus root b square minus 4ac whole divided by 2a. Applying the identity a square minus b square is equal to a plus b into a minus b, and simplifying, we get that is equal to minus b by 2a whole square minus root b square minus 4ac by 2a whole square. That is equal to b square by 4a square minus b square minus 4ac by 4a square, which is equal to b square by 4a square minus b square by 4a square plus 4ac by 4a square. Cancelling out the positive and negative terms, we get product of roots is equal to c by a. We know that the standard form of the quadratic equation is ax square plus bx plus c is equal to 0, where a is equal to 0. Dividing both sides by a, we get x square plus b by ax plus c by a is equal to 0. Substituting equations 1 and 2 in the above equation, we get x square minus sum of roots x plus product of roots is equal to 0. Form a quadratic equation whose roots are minus 3 by 2 and 4 by 5. Here it is given that alpha is equal to minus 3 by 2 and beta is equal to 4 by 5. The sum of roots is equal to minus 3 by 2 plus 4 by 5. Taking the LCM, we get minus 15 plus 8 divided by 10, that is equal to minus 7 by 10. Similarly, the product of roots is equal to alpha into beta, that is equal to minus 3 by 2 into 4 by 5, that is equal to minus 12 by 10. We know that the general form of quadratic equation when roots are given is x square minus sum of roots x plus product of roots is equal to 0. So, the equation becomes x square minus minus 7 by 10x plus minus 12 by 10 is equal to 0. 10x square plus 7x minus 12 is equal to 0.